Hi folks, we're going to take a look at page, I think it's 433, number 13 from the Unit 4 assignment. All right, so let's take a look at this question. So you have somebody here standing halfway between two trees. So while they do give you this total distance of 40, we know that it can be split up into 20 and 20. So this is not something we can assume unless they're actually telling us, which they are. All right, and so here looking at a blue jay on one spot and looking at a cardinal on this shorter tree, and then there's more information given. So from Nikki's point of view, the angles of elevation, okay, so remember angle of elevation is always from the horizontal to the cardinal and the blue jay are 60 and 50 respectively, all right? Or sorry, to the blue jay and the cardinal. So that means the first one is 60, which makes sense as you're looking up because it's the taller tree, so a bigger angle of elevation. So if we make this line, okay, and I'll make it all the way through from the horizontal, this is a 60-degree angle, and then to the other shorter tree is a 50-degree angle. All right, and they say that Nikki's 1.5 meters tall. Okay, so we can add that into the diagram. We want to find the height of each tree to the nearest tenth of a meter. All right, so lots of information given, so important to add that onto your diagram. So let's see what we can do here. So if we want to find the height of the tree, well, we already have the height to here, which is 1.5 meters on either side. Okay, that's where the observations are being made from. So essentially, we just have to determine this remaining height, which we see is part of this right angle triangle. And similarly here, this remaining height is part of that right angle triangle, since we assume the trees are going straight up. And we know that if this is 20 meters down here, we have 20 meters in each of those triangles. So because we have an angle and a side length in each of these right angle triangles, we can use our primary trig ratios. Okay, so that's what I'll do. I'll call this, let's call this x, and let's call this y. All right, so here I know the adjacent side, and I'm looking for the opposite side, so I'm going to use tangent here. So we have that tan of 60 degrees is equal to the opposite, that thing I'm looking for, over the adjacent, which is that thing I know. And then we see I have a very similar scenario on this right angle triangle here, opposite and adjacent. So I can write tan of 50 degrees is equal to the opposite y divided by the adjacent, which again is 20. All right, so let's calculate these, and then from there we can just add 1.5 to each to get the height of the trees. All right, so let's do that here. So here x is just going to be equal to 20 times tan 60. Okay, so here we have 20 times 10 60, which is 34.64. 0.64, and so here we can calculate the height of this is the bluebird tree, okay, and all we have to do is add 1.5 here. Okay, so 36.14, and everything's in meters. And now I'm going to do similar thing here. Y is just equal to 20, 10, 50. All right, so that's 20 times 10, 50 is 23.84. Okay, and you might be wondering, why am I showing all these steps? Well, in case, on a test you make a little silly error, showing all your steps shows that you know what you're doing. So here, this is the height of the cardinal tree. I'm just going to add 1.5 to that one there, and we get 25.34 meters. All right, so we've answered part A of this question. Okay, so this is A. And then in part B, it says, how far apart are the two birds? All right, and so essentially what we're looking for is this distance here. All right, but this distance isn't really related directly to these right angle triangles, but we see that this hypotenuse and that hypotenuse of the two right angle triangles is also a part of this triangle created with the length d. So I think what we're going to do is we should calculate these two sides. We'll call this Z and W. And if I look here, remember this was the horizontal. So if we know this is 60 and 50, we can easily calculate that angle there since the total is 180. So 60 plus 50 is 110. and 180 minus 110 is just 70. Okay, and hey, look what I'm going to have. I'm going to have two sides, okay, and with the non-opposite angle to both, so I'm going to be able to use cosine law in this triangle here. Okay, but some work to do beforehand. So let's start by calculating z here. Now, because I don't want to use an approximated side, I'd rather use an exact side, so I'll use the 20 and the z, so it's adjacent and hypotenuse, so I'm going to use cosine. So cosine of 60 degrees is equal to adjacent 20 divided by hypotenuse, which is z. Okay, and to solve for z, I have to do some cross multiplication. So I'm going to multiply the z and then divide the cos 60. So we have z is equal to 20 divided by cos 60. Okay, all right, so let's see what that gives us. So 20 divided by cos of 60, okay, is exactly 40. And then similarly here, again, adjacent and hypotenuse. So again, we'll use cosine. So cosine of 50 is equal to adjacent 20 over hypotenuse w. And again, do some cross multiplying. W is equal to 20 over cos 50. And so that's equal to 20 divided by cos 50 is 31.11. All right, and now finally I can use this triangle here and apply the cosine law. So d squared is equal to that whole expression, okay? But I know I'm going to have to take the square root anyways, so I'm going to do it right off the bat in one step. Okay, so cosine law says it's the sum of the squares of the other two sides. So 40 squared plus 31.11 squared minus 2 times the product of the other two sides times the cosine of the angle opposite d, which again we found to be 70. All right, and so this will give us the distance between them. So let's calculate this carefully here. So square root of 40 squared plus 31.11 squared minus 2 times 40 times 31.11 times cosine of 70. And we have 41.43 meters. All right, and there we have it. Okay, so this one here had a lot of steps, a lot of short, easy steps, but a lot nonetheless. So step number one was to take all this information that was given and incorporate it into our diagram. Okay, just reminders here, the only reason why I was able to split this up into 20 and 20 is because they told us she was standing right in between. All right, and then from there, I just found a strategy for finding the sides that I was looking for. Okay, that's it for this one.